Hello, my name's Caleb, and today I'm going to be teaching you about lists and Boolean expressions in Python. First up, we have lists, which you create by making a variable to assign it, giving it the operator, which is an equal sign, and then you format a list by using square brackets, and you separate values inside these square brackets by commas. So this is a shopping list, and it contains the items apples, grapes, and oranges. So we can print shopping list, and it will display our list of apples, grapes, and oranges. But let's say I only wanted one item on this list. I only wanted to print, say, grapes. So lists come with indexes, and each of these spots are assigned a number. Computers start counting at 0 though. So apples would be in index 0, grapes is index 1, and oranges is index 2. So if I wanted to only print grapes, then I would put shopping list and then in brackets 1 because it is in index 1. And if I run that, then we just get grapes. Let's say we had a longer list and we wanted to print only, let's say, the last 3. We only want to know what the last 3 are. Then we can print a range. And what you're going to do is we want to start with the third one, which has the index of 2. And then we use a colon or semicolon, I can never remember which one it is. And we pick the one we want to end on. So while this is the 4th index, because Python excludes, it has this exclusion thing. So instead of 4, we're putting at 5. So we want to go up to index 5. Obviously, there's no 5 index. But what it's telling is go up to the 5th index slot. And if we save and run that, you will see it prints a shorter list of only oranges, beef, and chicken, which is the last 3 in the list. If you wanted to change something on this list, for example, oranges to peaches, let's just comment that out real quick. Then you are going to type shopping list to call up the list, shopping list, and then oranges is in the 3rd slot, so 2nd index. So now we've called up oranges. So we've called the list, which is this whole thing, and then we've called the specific index, which is oranges. We add an equal sign, and then we say peaches. And we can uncomment this, so it'll just print the whole list. If I save that real quick and forgot to end that. So if we run that, then we see that even though it starts as oranges, it is replaced with peaches. But let's say we want to keep oranges, but we want to put peaches in, like, add it to the list already. So what we can do is we're going to remove this, and we are going to add dot append. And what this append function does is it's going to add whatever we have in here to the end of the list. So we're going to add peaches, and if we run that, then we see peaches has been added to the end of our list. But let's say we want to keep all our fruits just kind of right here at the start of the list and our meats at the end. Then what we can do instead is replace append with insert. And then before peaches, let's say we want to put it in where beef is now, but not replace beef, just kind of slot it in right there and push beef forward. Then we're going to come out here and put a 3 because beef is in the third index slot. So if we run that, then we see instead of replacing beef, we have just slotted in peaches right in front of it. But let's say we decide, what if I don't want to get some grapes? I don't really like them, and we want to remove it. Then we can call shopping list dot remove, and then you can type grapes. So you could type in the specific one, for example, grapes, and it'll find grapes. Or instead, you could call it like this. If you want to remove a specific index, this will do the same thing. It'll remove grapes, but if you don't know like what is in your list exactly, and you want to remove a specific spot, you could just do that. But so we're going to remove that and run it, and you can see that grapes has been deleted from the list. You can also sort the list by doing shopping list dot sort, and what this will do is it'll put your list into alphabetical order, like so: apples, beef, chicken, grapes, oranges, peaches. And if we want to simply flip the list, so the first is last and the last is first, then we can do reverse, which flips it. We now have chicken is the first and apples is the end. And if you want to find out how long your list is, you can use the function len, and then in parentheses the name of your list. And if you run that, instead of printing the list, it'll print how long our list is, which is 6. You can also add two lists together. For example, we have our list fruit and our list meat, and we can get a single list combining both those lists. So if we run this, then we see it just sticks the two lists and puts them one behind the other. Something else you can have is lists inside of lists. So say, we got our shopping list here, but we want it to be more structured. So inside of the shopping list, we're going to have the list of fruits and the list of meats. And so now, if we run this, we see that we have a list, which is these brackets right here, containing one list, two lists, which each contain their own items. And you could go, pretty much infinitely, just with lists inside a list, inside a list, and so on and so on. And each of these has its own indexes. So if we want to pull apples, it is no longer just 0, because the first item in the list is actually this entire list. If we run this, then we simply get the first list. So how do we pull just apples? Well, now that we've accessed the list in the first list with the proper index, then if we want to get apples, we add another bracket with another 0. So if we run that, then we get just apples. Beef would be 1, but it would remain 0 because it is the first item in this list. So if we run that, we get beef. And you could do all the previous commands that we did before with shopping list, like dot append whatever, dot remove. And if you want to do it to one of these specific lists, you simply add the index of that list. You don't just have to use strings, you can also use numbers and Boolean expressions, which is something I'm going to now be showing y'all. So something we could check is, so if we got a height of, let's say 50 inches, but to be tall, height has to be greater than 58 inches. I don't know how tall these actually are. I'd have to do math for that. These are just examples. But if we print tall, because what would tall be? Tall is height greater than 58. Like, what does that mean if height is 50? So what we get is a Boolean, which is a true or false. So what we're testing is 50 greater than 58? So is this person tall? And the answer is false. So something you can do, because you can do greater than, less than, but can you do equal? Because what a single equal sign means height is 58, not is height equal to 58. So how you do that in Python is a double equal. A single equal is height is 50. A double equal would mean is height 50? And if it is, then this will result in true. So tall equals height equals 58. So if we run that, that's false because height is 50. But if we change that to 58, then we get true. And if we change that to 59, then we get false again. You can also check for greater than or equal to. Height is greater than or equal to 58. Height is less than or equal to 58. Or even height is not equal to 58. That's going to wrap it up for this video. I hope you learned something new. I haven't posted in a while, but I'm going to try to be more consistent with video posting. And like and subscribe, and I'll see you next time, hopefully.